My name's Kwa, and I'm here to just teach about an introduction to AI, right? So we're just going to talk through the basics of AI. Some of you might have already attended, I know you've probably attended some stuff here. And so this kind of presumes that you have no knowledge whatsoever about AI, right? So we're just going to go through some of the basics. Some of the math and the engineering is going to be a bit hand-wavy, to be honest, right? So there's a lot of details, as you might imagine, about the math. There's a lot of details about the engineering or the coding, right? We're not really going to be talking that much about it just because, with AI now, like you kind of don't need to know it as much anymore, right? You need to know the broad strokes of what's happening in the field because you can actually code some really cool stuff even without knowing how to code, right? And so we're going to spend a lot of time probably later this week to teach you how to code stuff and build stuff without using coding at all, right? So it's kind of using the vibe coding techniques that everyone's using now. Okay. So our goals for today is to build an intuition for AI, right? So I want to give you a sense of what AI feels like, okay? And that's kind of like the goal of, of today. It's very hand-wavy of coding and math, like I said. Tomorrow, our goal is to bring you to the frontier of AI knowledge. So what is actually happening in AI now? Now, you might be a little bit skeptical in that, people have studied AI for decades and now they're understanding the frontier, right? But it's actually getting a lot easier to understand AI just because it's becoming more powerful, right? And so there's a lot of concepts that you can learn very quickly. And some of the stuff that we're doing, to be honest, is really low-hanging fruit, right? It's kind of like really basic ideas that someone was like, oh, like that's an interesting idea. I better spend some GPUs or CPUs on it, so some compute on it, and then they found something very basic, right? So you'll see some of the insights that we had as a field are still very basic, which I think is a very exciting thing because there's probably a lot more deeper insights that we have yet to kind of unearth, right? And it's kind of people like you who are going to bring us to kind of these deeper insights. And then finally, throughout the kind of 2 weeks, we're going to an opportunity for you to work on an exciting medical AI project, okay? So hopefully it's kind of, we're always experimenting. We've tried running a couple of things before where we got a bunch of medical students to build stuff with code and we found that it was quite successful, right? So we're trying to extend it a little bit further, right? Like give you guys a bit more support and see what you can build. Okay, so teaching philosophy-wise, my teaching philosophy is that medical AI can be learned, practiced, and perfected honestly by anyone, right? And so your expectations of me or my expectations of you. So I want to create a welcoming environment so that you can actually engage with this. If you have any questions, just interrupt me, stop me. If you don't understand something, just please ask, okay? My goal is also to explain concepts clearly, right? So that is, we want you to develop an intuition for AI, not so much like the kind of nitty-gritty, because the nitty-gritty, unfortunately, it kind of changes quite quickly, right? So if you learn all these fancy formulas, in like 5 years, the fancy formulas will change, right? But the people who do really well in this field are those who have a gut feeling for where AI is headed, not necessarily the formulas itself. In terms of participant expectations, so what I expect from you is that I want you to bring a beginner's mindset, okay? So that is something that, this is a field that you don't really understand and that's perfectly okay, right? I want you to kind of have an open mind about the stuff that I teach, as well as be curious. So ask questions, right? There's going to be lots of questions that I probably won't be able to answer, but I think that's always an interesting thread to pull on if you ask really good questions. And I want you to actively support and contribute to the innovation community after you finish this, right? It's a really kind of tight-knit community in Australia. And so, whatever you learn, like share it with others, whatever, if you end up like going into the field, like keep on teaching other people, right? Because, people younger than you are going to want to learn about this. Okay. So in terms of agenda, so today we're going to talk about, so we're doing a welcome and introduction right now. We're then going to shift to the history of AI, right? So the history of AI is really important just to see like where we've been in the past and where we're kind of going now, okay? And then we'll talk about some fundamental technologies that have shaped modern AI. Firstly, which is the neural network and deep learning. So just really basic concepts from those, followed by transformers and large language models, which Transformers was, as you'll see, something that was published in 2017, but people kind of ignored it for 3 or 4 years before in 2021, people started to take it as a very serious idea. And then ChatGPT was released in 2022. Okay, so it was kind of like the foundation of everything that has happened with ChatGPT. Okay, so Transformers is something quite big, and so we'll talk about that. Tomorrow, we'll talk about a little bit more of the practical side of AI, right? So today is a bit more technical. Tomorrow is going to be how to kind of think about AI, how to kind of practically use AI today. And then we'll talk about some of the future directions of AI. So things like novel architectures, novel interfaces, AI agents, which has become this very big thing this year in particular. So AI is becoming very powerful because of agents. And so we'll walk you through what the foundations of AI agents are. We'll then talk about a couple of things that are very important for medicine itself. So the first is AI interpretability. So do you even understand what is happening in these black boxes of AI, right? Like how do we kind of figure that out? As well as AI security. If you're going to put patient details into an AI, you don't want people stealing some of that stuff, right? So we're going to talk about some of those trends there as well. Okay. And then on Wednesday, we're going to kind of shift tack and then talk about the competition as well as biodesign basics. So biodesign is a methodology from Stanford University, which a lot of entrepreneurs and students there are taught. And it's basically how to bring a project into real life, right? I think like a lot of doctors, unfortunately, aren't taught that. And so a lot of people will do research, but have absolutely no idea what to do afterwards, right? It's very easy to design a research project that is, in a safe environment. You can't just test if it works, right? But then what do you do afterwards, right? There's like a whole 10 years afterwards of expertise and knowledge that you need to kind of bring something into fruition. And so we'll talk a little bit about that. Okay, so I've already covered the welcome and introduction, so we'll start at the history of AI. Some of you may have already seen this before, but we'll go kind of in detail. So AI has been something that humans have always dreamed of for quite some time. And the very first kind of whispers of AI in humanity was this thing called the Mechanical Turk. Now, does anyone know what the Mechanical Turk is or was? No? Okay, so it is actually a chess playing machine built in the 1700s. Okay, so back in the 1700s, chess still is a very popular sport. And so someone invented this device whereby there's a chess playing robot, right? And so, it actually toured around Europe, it toured around the Middle East, and, it got a lot of big press because there was a chess playing robot, right? And it beat everyone that, was on tour, right? Or like tried to verse it on tour. And what they eventually realized about 100 years after this went on tour was that there was actually a chess grandmaster hiding inside the box. So it looked like they were basically puppeteering this Turk so that they would play different chess moves, right? And so we've had dreams of robots. This was unfortunately a hoax, but this was kind of one of the very first, whispers of AI that we found in humanity. Fast forward 200 years, and then we have this very famous conference called the Dartmouth Conference. And these 10 gentlemen here all came together and decided to coin the term artificial intelligence. Now, I don't know if you know some of these people. Some of these people are, experts in computer science, experts in mathematics. So AI, obviously, before it was founded, was just kind of a disparate collection of different fields, right? And some of these people came together and, kind of realized that you could actually build intelligence through artificial ways, right? Through ways that aren't human. And so they decided to define the field, kind of, think about what experiments for the field could look like. And they were very bullish as well. They thought that AI would be solved within 5 years. Okay, so they were very, very kind of confident about that. And they led to this field called good old-fashioned AI or symbolic AI. And because, a bunch of them are mathematicians and computer scientists, they define intelligence to be logic-based, entirely logic-based, right? Now, if anyone who's ever studied math or philosophy might understand this, right? These are a bunch of logic signs and symbols, right? So they actually created an AI that could prove a lot of theorems, mathematical theorems, right? And so people got very excited, but then they realized through what was known as the first AI winter, that you cannot use logic in everything in life, right? Like not everything in life follows clear mathematical logic, right? And so that led to what we know now as the first AI winter, where funding completely dried up and then no one did AI research anymore. And so as you'll see, as we kind of go through the story, that there's a lot of summers and winters in AI. Okay, right now we're in a beautiful summer, but we may go into a winter at some point. Then in the 1970s and 80s, this field called expert systems led to the second AI summer. And how expert systems work is it's a bunch of if and else statements. So if you might know a little bit about coding, right, we rely a lot on if and else statements. So it's just basically, if this condition is true, then you do this. If it is false, then you do this, right? And if you kind of build very complex decision trees, it starts to mirror some of the complexity you might see a little bit better than logic, right? So a very classic example, is the Australian kind of ACS guidelines, right? A lot of medicine actually follows a bunch of if and else trees, right? It's just like, if the patient has any of these features, or no to all, and they have a TIMI score less than 1, then you have to do this. If it's not, then it's this. If it's yes to any, then you do this. So you see how medicine itself, parts of it are constructed based off if and else trees, right? So expert systems were very powerful for medicine. And so there was a lot of excitement in our field, right? So this was a very famous experiment or a very famous system from Stanford University in 1975, whereby they built a system with over 600 rules to provide what antibiotics should be given to a patient. Okay, and that system actually outperformed the vast majority of Stanford ID physicians, right? Infectious disease physicians. So again, we were already building very powerful systems in 1975, just based on simple rules that humans would follow for a certain clinical situation. Now, the same thing was built at the University of Pittsburgh. They basically had an internal medicine specialist who was like the best internal medicine specialist in the United States, the whole of the United States. And he had built up almost like an encyclopedic knowledge throughout his entire career. And so someone decided to sit down with him and created a system that could diagnose over 1,000 diseases, right? They just pulled out all the information from his head, right? And this system became known as Internus I, and it outperformed the vast majority of physicians. So we already had this kind of technology even back in the 1970s, right? Kind of those ideas of, can we use AI to diagnose different conditions? All right, unfortunately, as we all now know, expert systems, not everything in reality can be broken down into if and else rules. A certain subset of human knowledge can be done so, but not everything, right? And so this led to the second AI winter, where again, funding dried up, no one was able to do AI research. And this lasted for quite some time. So the kind of 1990s and 2000s, you'd be kind of caught dead trying to do AI, right? Because it was a very, very unpopular field. And then in the 2010s, this kind of technology, which we'll cover through in a little bit, called neural networks, was invented and became very powerful for statistical learning. Okay, so it's a very powerful statistical model. And so now we could basically employ AI to model different statistics, different kind of inputs and outputs. Okay, so a lot more complex than if-else rules, as you might imagine, right? But a lot more mathematical, right? So neural networks kind of led to this thing called deep neural networks or deep learning, whereby someone realized that if you continue stacking a bunch of layers, then it gets more and more powerful. And then in parallel, we also had better GPUs, so that is better compute power, so the ability to actually compute and calculate different mathematics, as well as more data. And so this also led to the discovery of different types of architectures, which are all neural network related. So someone invented in 2012 what is now known as the convolutional neural network in order to identify different objects in images. And the inspiration for this is actually retinal fields. So someone kind of just looked at, how the retina worked. They were like, the retina is a great kind of image recognizer, right? So how does the retina work? It has retinal fields. And so they built this very simple neural network whereby you basically look at pixels around a center pixel there in order to identify different things, right? So it's just kind of the basic intuition that if you're looking at this pixel, for example, the pixel next to it will be important in some way. So it's dealing kind of with place, okay? In 2016, someone used a very old technique, which is actually based off Pavlovian learning. So if you remember Pavlov's dogs, right? Someone managed to construct a mathematical model based off that. And then they termed it reinforcement learning, kind of based on the fact that if you have a positive feedback loop, then you can learn something. If there's a negative feedback loop, then you kind of stamp out that behavior. And it led to very complex kind of behavior, right? So someone built a reinforcement learning software to solve the game of Go, which I don't know if anyone knows that game. It's a very complex Korean game or Chinese game that is a lot more complex than chess. I think the number of potential positions is more than the number of atoms in this universe, right? So it's quite a complex game. And they managed to use this in order to solve this game and kind of beat the best player in the world at it. And then in 2020, so we'll talk a little bit more about this, Transformers started hitting the AI research world, we're not going to kind of break this down. Hopefully you might actually understand how to read this later today. But this kind of architecture has revolutionized how we think about language in particular, which is why ChatGPT is a language-first model, right? Obviously now it can deal with images, it can deal with things like video, that kind of stuff. But initially when it was launched, it was primarily a language model, okay? And someone at Google basically put together this architecture that optimized for dealing with language, okay? So we'll talk about how they did that in an intuitive way. In 2023, GPT-4 was launched. So there was an earlier version called GPT 3.5, which was launched about 6 to 12 months earlier. And as you probably all know, it kind of hit the mainstream, the concept of AI. A lot of people hadn't thought about AI before ChatGPT came out. And a lot of people think ChatGPT as synonymous with AI, right? And so very kind of interesting to track the history of this. In May 2024, we've now shifted from purely language models to multimodal models. So models that are capable of dealing with things like audio, images, and video, right? So that is, these models can now kind of see, speak, and hear and understand the world through different ways. Okay, so kind of very interesting there. In September 2024, so this is now just about a year ago, OpenAI released what was known as the first reasoning model. So that is a model that can reason, okay? And we'll talk about how they actually did that, as well as why it's very powerful. But it's now become the default for all models. So if you talk to ChatGPT, you'll see that it actually thinks for a little bit before answering. It used to be, before a year ago, that it would just immediately answer, right? But that thinking has really brought a lot of, I guess, like thoroughness in answering very difficult questions. So things like math or medicine or, whatever it might be, it actually thinks before it speaks, right? Which is a very kind of, if you think of a human, it's better that someone thinks before they speak, right? Rather than just spits out the first answer that comes to mind, right? So again, another very powerful paradigm. In February 2025, we now have agentic models. So these are models that are capable of looking at the environment it's in, thinking about the different actions that it should take, and then deciding to take those actions and kind of repeating on a loop, right? So you can see how you can ask, this is a Perplexity browser, to actually look at different bikes for you, right? And then see if it can weigh up which bike might be the best and then purchase it for you. So you see how it's becoming more and more complex, the different tasks that it can actually think about and consider. So kind of very interesting to see the different interfaces. Again, some of these companies are thinking about, instead of just a chat interface, it's now a browser, right? So you can actually browse the internet. It becomes kind of a big playground for the AI. All right, and then finally, and this is kind of more recent, so October this year, transformers are starting to hit robotics, right? And so it's kind of using the same principles in that these robots now have an understanding of the world, right? So previously robots, you had to really pre-program a lot of stuff, right? Or there had to be like a human kind of controlling it. But now these robots can actually look at things and see things. So, it can do, honestly, very, very challenging things, which is even stacking like a dishwasher, which we take for granted, but are very hard for robots to do, right? And there's this very famous rule called Moravec's paradox, which basically says that something that is easy for a human to do is really hard for a robot to do, because we've had millions of years of evolution on that functionality, right? So say, for example, like, you ask me to walk over a pile of rocks, I'm able to because of millions of years of evolution, right? But something like thinking, I consider to be harder, right? Because it's kind of later developed in human development, right? Robots, on the other hand, will find things like thinking very easy, but things like walking over a pile of rocks or stacking a plate of dishes or filling a fridge full of groceries, very, very difficult, because it requires stuff that has been heavily optimized by evolution for us, right? So it's a very interesting paradox. Take a look at it if you're interested. But transformers are starting to hit robotics. And now there are big questions right now in the market as to whether we're going to enter a third AI winter, okay? Now this has been a famous kind of graph that has been hitting a lot of the AI world, in that just how much self-funding the AI field has been doing, right? Like a lot of companies are funding each other. NVIDIA's seems to be funding everyone, and they're funding NVIDIA, and so there's a lot of kind of feedback loops that are, if kind of one of these companies crashes, then it might bring down the whole system, right? So big questions right now as to whether we're going to hit a third AI winter. We're also starting to see that AI has hit a little bit of a plateau in terms of performance, right? Now, why is that? It's a little bit hard to say, but companies are now starting to think about building products rather than just kind of improving the underlying AI. Okay, so kind of very interesting to see. Okay, any questions on that before we move on to neural networks? Yeah, as in how transformers work, or what do you mean?
Well, yeah.
Yeah, we're going to talk about that like in the, yeah. Yeah. Any other questions? How have you kind of been thinking about AI I'm kind of curious, right? Because I suppose I've seen AI like, this kind of large language model stuff happen a little bit later in my career, right? How are you thinking about it given that it's happening like early in your careers? There was this like very interesting, I was listening to this podcast and someone was saying that, with the internet, right? Like it was an older kind of professor, and he was saying that with the internet, he managed to live about half his life before the internet came along, right? And he was very thankful for that because he could see what life was like without the internet before now appreciating the internet, right? So it's kind of like, I guess it's not half my life yet, but it's like I lived a fair amount of my life, right? Including most of my university without AI at all, right? And then now I'm seeing AI in my career, but I guess like the reverse is, like you are living through university with AI, right? So how do you kind of think about that, or like how do you kind of see the trajectory of that?
Perspective,
Yeah. Yeah, actually, Deepak will give you a mic. Yeah.
So I think we are more better off.
Oh, yeah, sweet.
Like
if you just hold it like
right. So from a perspective of people in high school, I feel like they're at a disadvantage because they didn't really kind of develop the basic needs that you need to build on your whole career.
Yeah.
While we have been through high school in a sense, so I think we are better off using both, like, our brains with collaboration with AI.
Yeah.
So
Interesting. I mean, do you feel like your writing skills are worse or better now with AI? Or like, can you even write anymore? I don't know. Like, no, I'm honestly asking because I feel like I can't even write anymore, right? Like, I find it too much to be of a mental burden, right? Such that I'm just like, all right, like, here's some dot points. Can you just write it for me, right? Do you guys do that as well? Okay. So, like, is anyone like a fan of writing? Like, as in, like, they like writing? Grace, I see you. Does anyone like write? Like, has anyone written any, what I mean? Like, they like writing, like, short stories or like, that kind of stuff? No? Okay. What about like math or like, do you feel like you outsource work or like, what I mean? Like, or studying to AI? How so? Yeah.
I think it's just become like inevitably like a key part of my life almost.
How
Just like
so? Like, as in like do you talk for it about decisions and stuff or
yeah,
not?
I just use it for like so many different like cases. So for
Yeah.
example, the other day I was just looking at like housing and just for like rent and stuff.
Yeah.
And I just used it to like compare all the different
Yeah.
houses. I put in all my information, not the
Yeah.
important things, but like
Yeah.
and then it kind of solves it just kind of solves all my issues for me these days.
Yeah.
So I just can't imagine a life without it anymore, honestly.
Sounds like an addiction. That's okay. Yeah, cool. I mean, it's so interesting because I feel like my generation's a little bit less okay with that, right? But like, I can't imagine like, I feel like if I was younger, I would definitely just use it for everything. You know what I mean? Like anything and everything. Um, Very interesting. Okay. Any questions about the history of AI or the past or the present or the future, right? Like, do you kind of understand, I guess, like, the kind of spectrum in which we're moving, right? So obviously one spectrum is how autonomous AI is, right? So it used to be that AI was very dependent on humans, right? But in like decreasingly so, it can just, or increasingly so, it's just going off on its own and doing stuff, right? Which means that people are starting to become managers of AI itself, right? Like a big skill that a lot of people are talking about now is, if you can manage like 20 humans, you can manage 20 AIs, right? Or if you can manage 100 humans, you can manage like 100 AIs, right? And so you suddenly have a team of not people, but AIs at your disposal to do kind of whatever you want. And the people who will become kind of most powerful or most rich or whatever will be those who can basically deploy like thousands of AI to do stuff for them, right? And that's kind of like a very powerful paradigm. Any thoughts? Drew, what do you think? Yeah, you're looking straight at me.
Yeah, I think I echo a lot of the
Yeah.
sentiments that everyone else has shared. I think I use like AI like every single hour of my like waking life.
Okay.
To like I
Okay.
think it just like augments like your intelligence a lot. And I think I use it for like everything.
Yeah.
Like when it comes to like, I don't know, like working out, if I like need a workout, I just tell it like what equipment I have and it just like
Yeah.
creates something. Or if I'm like, oh, like here are all my like blood tests and documents, like what should I be doing? Or if it's like genuinely for everything, even for like maths and stuff, like it's
Yeah.
like pretty crazy like to see like the progress.
Yeah.
And like every like new AI model that comes out, it's like, oh shit, like we've reached the top kind of like
Yeah,
happening
yeah.
like it's reached a point where like I can't really test like how smart they're getting because I don't know.
You
It's
don't
like
even know how
beyond my
smart.
limits.
Yeah, it's beyond your limit.
Exactly,
Yeah.
yeah. Like I think like a new like image model came out recently,
Yeah.
like Google like Gemini 3 or whatever. And then it created like this insane like flow chart of like this all these like valvular diseases.
Yeah.
And I had to like paste it into like another AI to like ask it like, wait, is this like true or false? So I think it's like pretty crazy because like
Yeah.
because like that like you know like last year would have been like science fiction.
I was
And
just seeing some stuff yesterday actually on that, like Gemini 3. I don't know if you guys have played around with it. I've heard it's a little bit unstable. Just got released like 2 days ago, right? But people are shocked at the capability because you can, like you said, like ask it to create a lesson plan or something for like something, right? Like could be valves or could be, I saw one about how planes fly, because one of the Google execs wanted to create it for his daughter. And it was insane. Like it built like a whole lesson plan about how planes flew and it was all accurate, right? Which is just, it created diagrams, it created like, figures and stuff you could understand, right? Like it's crazy, right? Like that's insane to me, right? How do you guys think about like using it for things like making money or like stuff that, I don't know, right? Like has anyone tried to use AI to make money? Oh yeah. Okay. Yeah. Maybe when you, yeah. But it's kind of like, people use it to run companies. People use it for stuff that you don't even expect right now, right? And so a little bit of that is like trying to expand your mind about what you can actually use AI for. And it might not work, but it's worthwhile testing, right? When Eric Schmidt, who's like the ex-Google CEO, gave a similar talk at Stanford, right? The undergrads, so people kind of your age or even younger, were asking like, how can they use AI to do the next big startup, right? And he was like, well, TikTok is going to get banned. It's no longer going to get banned, but at the time, like we all thought TikTok was going to get banned, right? So he was like, you should just use AI to create a bunch of like 1,000 TikTok clones, and then one of them will get traction. And then, and then you just like, live off the proceeds of that basically, right? So it's kind of like you should be thinking more broadly about how you can use AI, I think like a lot of people fall into the habits of, what they're used to, right? So like a very famous study I'll talk about, I think tomorrow, is when you compare doctors and AI versus AI, the AI itself does better, right? And part of the reason why is because doctors use it like Google, right? So they use it when they need to search something rather than as like a co-participant in diagnosis. Do you see what I mean, right? But I presume, and they didn't test this though, but I presume the doctors who are probably younger and using it as like, this kind of partner would do a hell of a lot better than just AI alone as well, right? So it becomes kind of this strange paradigm where, those who can use AI very effectively, right, for ways that people just cannot imagine, right, will become very, very kind of good at what they do, right? So kind of interesting to think about.